8-2 homework, problem number 6. A force of 125 newtons is applied to begin the rotation of a pottery wheel. The pottery wheel has a radius of 0.45 meters and a mass of 3.75 kilograms. What angular acceleration does the wheel have, and what is its angular velocity after 15 seconds? This problem, writing down everything that we have, we know that there's a force of 125 newtons being applied. The wheel has a radius of 0.45 meters and a mass of 3.75 kilograms. It starts at rest, so omega I, the initial angular velocity, is 0 radians per second, and it spins for 15 seconds. Two equations. We had two equations for torque. The first one was that torque was equal to force times the radius. We have the force and the radius, so we could solve for the torque. The other equation for torque was that torque was equal to I alpha, I being the moment of inertia and alpha being the angular acceleration, which is what the problem was asking for. So if torque is equal to Fr and torque is equal to I alpha, then Fr is equal to I alpha. And if we rearrange that, we get that alpha is equal to force times radius divided by I. A pottery wheel is considered a solid cylinder, and therefore I is equal to 1/2 mvar squared, just like it was in the previous problem. Substituting, alpha is therefore equal to F times R divided by 0.5 mr squared. R on the top in the numerator cancels out one of the r's that are in the bottom from r squared, leaving us with F divided by 0.5 m times r. Substituting in our numbers now, we have 125 newtons divided by 0.5 divided by 3.75 and divided by 0.45, which comes out to 148.148 with the 148 repeating. Rounding to two significant figures, this comes out to 150 radians per second squared. Moving on to the second part of the problem requires us to determine the new final velocity after 15 seconds. We know that omega I is 0, and we know it's 15 seconds, and we know alpha from the first part of our problem is 148.148 with 148 repeating. From earlier in this unit, in chapter 8, we had an equation for angular acceleration which stated that alpha, angular acceleration, was equal to omega F minus omega I divided by t. If you rearrange that solving for omega F, you get alpha t plus omega I. Plugging in our numbers, we have 148.148 times 15 plus 0. This comes out to 2,222.2 repeating. Rounded to two significant figures, rounds to 2,200 radians per second.